Good morning, class. So in this live lesson recording, we're going to be going over Unit 4, Lesson 10, which is the portfolio for Unit 4. This is all about scientific notation. So a couple things to note here. First of all, that you only need to complete questions 1 and 2. So there are 4 questions total. You only need to do questions 1 and 2, which will actually take a little bit. It's not like I'm cutting out a lot, but there's still quite a bit left to do. So it says you can use this worksheet to complete the portfolio. So just so you know, this is just a document that was created. It's a Google Doc. So you can fill that out. If you want to do that, like if you want to fill out this version of it and be able to just type in there, you'll have to do File, Make a Copy, or Download. So you can either do Make a Copy and then you can edit it yourself, or you can download it as a Microsoft Word document. Would be probably the best option. So make a copy or Microsoft Word. However, what I would recommend is just to do the regular assignment. So this is the assignment here. It's a PDF. So when you open the PDF, you probably the best option, and it says all this down here as well, you probably want to open it as in Microsoft Edge. The reason why you want to open it in Microsoft Edge is because Microsoft Edge gives you the tools to type in it, to draw in it, to highlight, whatever. So like that's what I use in live lesson whenever I'm drawing. So I would recommend using Microsoft Edge to edit this. So first of all of these are, like if you click in the text box, whoops, you don't want the text box. I don't want that. All right, so if you click in that box, you can just go ahead and type. So these are all like editable already, even if you're not using not using Microsoft Edge. However, if you use Microsoft Edge, you can also draw on it. Okay, so question number 1, it says choose 2 scientific numbers. So this is part A. So there's a list of scientific notation numbers that we're going to add, and we only have to choose 2 of them. So when we choose 2 of them, we want to choose numbers that are close to each other, and you can use the same numbers I'm using, so you don't have to like do your own numbers. If you want to use the numbers I'm using, you can use them. So I'm going to choose these 2 because they're the closest. The reason why is because you always have to convert to the highest exponent. So this one is 10 to the 4th, this one's 10 to the 6th. In order to add them, they both have to be 10 to the 6th. Or both 10 to the 4th, but that would be silly. You always want to convert to the larger exponent. Okay, so we're going to convert this to 10 to the 6th. So in order to do that, 3.2 times 10 to the 4th, I'm going to move the decimal place over twice. So I'm taking away 2 powers of 10 here, and I will add 2 powers of 10 here. So it's 0.032 times 10 to the 6th. Okay, and to that, I'm going to add this other number, plus 1.95 times 10 to the 6th. And now all we have to do is add the coefficient. So 0.032 plus 1.95 is 1.982 times 10 to the 6th. You could use a calculator. So all I'm doing is I'm adding these 2 coefficients, so this number and this number, to get 1.982, and then the 10 to the 6th just stays 10 to the 6th. And that's it. All right, so since I've already converted that number, for the next one, it says choose 2 of them. You can use the same 2 numbers. So I'm going to use the same 2 numbers, again, because they're the easiest numbers to use anyways. So now I'm just going to subtract this same number. So 1.95 times 10 to the 6th. And I'm going to subtract the other number because it's the smaller of the 2. So 0.032 times 10 to the 6th. Okay, so remember, that's technically this number. It's just I've converted it to 10 to the 6th. Okay, so now I need to subtract these. So that is going to be 1.95 minus 1.9. Gotta move this out of the way. 1.95 minus 0.032 is 1.918. So 1.918 times 10 to the 6th power. And that's it for that one. Okay, so now we're going to multiply 2 numbers. I'm actually just going to keep using the same numbers because it's easy. So 3.2 times 10 to the 4th. So now when we multiply, we don't need to convert. So we're multiplying that times, what was the other number? 1.95 times 10 to the 6th. Okay, so when we multiply the coefficients, so 3.2 times 1.95. So let me clear this out. I'm just going to hit enter. So 3.2 times 1.95. So that's the coefficients multiplied as 6.24. And then we add the exponents. So 6.24. So I multiplied 3.2 times 1.95. And now I'm going to add the coefficients because that's 10 to the 4th times 10 to the 6th. So 10 to the 4th times 10 to the 6th. Remember, you add the exponents as long as the base is the same, which, of course, in this case, they're both 10. So we can just add the exponents. So that would be 10 to the 10th. So 6.24 times 10 to the 10th power. And that's our final answer. And just to stick with the theme, we're going to use those same numbers again, only this time I'm going to switch them. So I'm going to use 1.95 times 10 to the 6th. You'll see why I did that in just a second. Divided by 3.2 times 10 to the 4th. So with this, we have to subtract the exponents. So 6 minus 4 would be 2, whereas if I did 4 minus 6, I'd have negative 2. And I want to keep that exponent positive. Okay, I guess it wouldn't have mattered. Oh well, we're going to go with it. So we're going to so first thing we're going to do is we're going to divide the coefficients. So we have 1.95 divided by 3.2. Now notice that this is a number less than 1, so I'm going to have to convert that. So I'm going to use 0.609. I'm going to cut it off there. So 0.609, we're going to round it there. So 0.609. So that's equal to, and then I subtract the exponents. 6 minus 4 is times 10 to the 2nd, because 6 minus 4 is 2. Okay, and now, again, to convert this number to scientific notation, this number has to be between 1 and 10. So I need to move this decimal place over 1. I'm adding a power of 10 here, so instead of being 0.6, it's now 6. So I have to subtract a power of 10 here to keep it the same number. So if I add a power of 10 here, I subtract a power of 10 here, or vice versa. If I subtract a power of 10 here, you move the decimal place to the left, then I would add a power of 10 here. Okay, so 6.09 times 10 to the 1st, which is really literally just 6.09, because, or sorry, it would be 60.9 because that's 10. So 60.9 would be the final answer there, but you can just leave it like this. All right, now this one says to add 32.8 to any number on this list. So we're going to pick this one. So the reason why I'm picking this one is because it's just a small decimal, so it'd be easy to add. So 2.56 times 10 to the 2nd. Whoops. What was that? 2.56 times 10 to the 2nd. So 2.56 times 10 to the negative 2nd. Okay, and I'm going to add this number to it. But first, I want to do what I want to do is convert this to decimal notation. So to do that, it's a negative 2 exponent. So I'm just going to move the decimal place over twice. So it's 0.0256. 0.0256. And now that it's in decimal notation, I'm going to add 32.8 to it. Okay, so that's going to be easy because you could use a calculator at this point, but you don't really need to, probably. So 32.8 and then 256. And that would be it for that one. So there's a decimal here, 32.8256. Okay. Choose one of the scientific numbers on the list and subtract it from, or subtract. Okay, so this one we can subtract this number from a number, or we can do the opposite. We can subtract one of those numbers from that number. Okay, so I'm going to do this one, 3.2 times 10 to the 4th minus this. Okay, so 3.2 times 10 to the 4th, and then I'm whoops, that's supposed to be an exponent. Doesn't really look like an exponent. 10 to the 4th. There we go. Okay, so first thing I want to do is I'm going to convert this to, there we go. Okay, I'm going to convert this to a number in decimal notation. So I'm going to move the decimal 4 places to the right. 1, 2, 3, 4. 1, 2. So I'm going to add in the zeros. 32,000 is what that number is. 3.2 times 10 to the 4th is the same as 32,000. And then I'm just going to subtract out the number it told me to subtract, which is 1,845.19. Okay, so we'll just use a calculator to keep it simple. So we have 32,000 minus 1,845.19. I think that's the right number. Let me double check. 1,845.19. That is correct. And we get 30,154.81. So our answer is 30,154.81. That is it for that one. Let me double check that answer. 30,154.81. Yep. Okay, I got it right. All right, next one. We are going to multiply this number times one of the numbers. Okay, so we're multiplying 256 times some number. So I guess this one doesn't really matter. We'll just keep it simple and do 3.2 times 10 to the 4th again. All right, so this one you could do a couple different ways. You could turn it into 32,000 again, or I can convert this number to scientific notation. So that's what I'm going to do for this one. I'm going to convert this number to scientific notation and keep the final answer in scientific notation. Okay, so this would be 2.567 times 10. I move the decimal place over twice, so 10 to the 2nd power. All right, so I'm multiplying that times 2.567 times 10 to the 2nd. And again, remember to multiply. We multiply the coefficients, so 3.2 times 2.567. All right, so 3.2 times 2.567. Oops, I missed the decimal point here. All right, we're going to have to go back. 3.2 times 2.567 is 8.2144. Okay, so 8.2144. So I multiplied the coefficients, and now I add the exponents. So 4 plus 2 is 6, so times 10 to the 6th, and that would be our final answer. All right, next one, we are going to divide one of the numbers by 0.3. So let's just keep it simple and just do the same number again. So this one, I'm going to divide this number by 0.3. So 3.2 times 10 to the 4th. And now I'm going to convert 0.3 to a number in decimal notation just to kind of keep it simple. Or you could do 32,000 divided by 0.3. That actually would be really simple too. But we're gonna use scientific notation. So I'm going to move the decimal place over one place to make it a number in scientific notation. So 3 times 10 to the, and I had to move the decimal place over, so I subtract a power of 10. So 3 times 10 to the negative first. Okay, so 3.2 times 10 to the 4th. So I'm going to, again, divide the coefficient. So 3.2 times, divided by 3. I think I said multiply. It's actually division. So 3.2 divided by 3 is 1.0. I'm just going to round it to 1.07. So that is, that's equal to 1.07, roughly, approximately equal to. All right, and then we subtract the exponent, so it's 4 minus a negative 1. So remember, when we subtract a negative, we're actually adding. So it'd be 4 minus a negative 1 is actually 4 plus 1. So that would be to the 5th power. So 1.07 times 10 to the 5th, approximately. That's it for letter H. All right. For number 2, it says we are planning a trip where we start at one city. So we're just going to pick a random city, like let's do Boston. All right, so we're starting at Boston. And then you travel to a second city. So we'll go Boston to Baltimore. So Boston to Baltimore. And then return to the original city, so back to Boston. Okay, so Boston to Baltimore is what we're looking at is we're looking at this chart, and it says Boston to Baltimore is this distance. Okay, so Boston to Baltimore is 5.7785 times 10 to the second power. So it wants us to write the answer in decimal notation, scientific notation, show all your work. Okay, so then we're going back to Boston, so it's like how far are we traveling? So really we're just adding this number back to itself, because obviously to go back to from Baltimore to Boston would be the same distance. So we add to that 5.7785 times 10 to the second. Those are pretty close cities to each other, so that's why the number's not very big. Okay. So now we just add those two numbers. So we're going to add the coefficients, but in this case, when we add those two coefficients, it's going to be a number greater than 10. So it was 5.7785 plus, now technically I could just multiply by 2 because it's 2 of those, but we're just going to add them. I forgot the decimal. 5.7785. All right, so we get 11.557. So when I add those two together, I get 11.557 times 10 to the second power. Okay, but I have to move the decimal over here. So I'm taking away a power of 10 here, so I have to add a power of 10 here. Okay, so this becomes 1.1557 times 10 to the third. So that's in decimal notation. That's miles. Now I need, or sorry, in scientific notation. Now I need to make that number decimal notation. So I just move the decimal place over 1, 2, 3 places. So that's 1,155.7 miles. So all I did was I took the decimal point, moved it over 1, 2, 3 places. So the decimal point would go here. So in between the 5 and the 7. So I just moved it over here. All right, so these are our two answers. That is the distance between Boston and Baltimore and back to Boston. All right, and then letter B, this is, I think, the last one. Oh, no, we're doing letter C, I think, as well. Yep, that's it. So then 2 more questions. Okay, so it says, Sita lives in Los Angeles and her grandmother lives in Seattle. Sita plans to visit her grandmother 3 times in the next year. What is the total distance she will travel to make these 3 trips? Okay, so she's going from Los Angeles to Seattle. 3 trips. Write and evaluate an expression that uses multiplication and calculate the total distance traveled. Give your answer in decimal notation and scientific notation. Okay, so whatever that, so we're going Los Angeles to Seattle. So that's this distance here. Okay, so 1.5442 times 10 to the third. So 1.55. Oops, no, 5442. Okay, so 5442 times 10 to the third. So that's the distance from Seattle to Los Angeles. So if you think about it, if she does the trip 3 times, so she's going from Los Angeles to Seattle and then Seattle to Los Angeles, that's 2. So that she's doing that distance twice. Okay, but she does it 3 times. So actually she's making this distance 6 times. because she's going there and back, there and back, there and back. So that's a total of 6 times doing this distance. So I'm just going to multiply by 6. Okay? In this case, if you want to put it in scientific notation, it'd be 6 times 10 to the 0 power, because she's doing it 6 times, which times 10 to the 0 is literally just times 1. So 6 times 1 is literally just 6. Okay, so I'm going to make this one this dot for multiplication. Okay, so now we multiply the coefficients. So 6 times 1.5, 4. 6 times 1.5442 is 9.2652. So 9.2652. I hope I got that right. 2652, yep. And then we add the exponents. So 3 plus 0 is 3. So 10 to the 3rd miles. So that's the distance she is going to travel over those 3 trips back and forth between Seattle and Los Angeles. And now we also have to write it in decimal notation. So just move the decimal place over 3 times. So that's 9,265.2 miles. So I move the decimal place over 3 places because it's 10 to the 3rd. So I move it over 1, 2, 3. The decimal would go right here. And so that's why it's here. So 9,265.2 miles is the distance between Seattle and Los Angeles, back and forth, 6 times. That's it for that one. All right, last thing that we're going to do for this worksheet. It says, using the table of distances, make up your own word problem that would require someone to use division to solve, write the problem, and provide the solution. Okay, so we need to come up with a division problem. Okay. So this is going to be a weird one. So we're going to do, someone's flying from Los Angeles to Tampa. Okay. So I'm going to just write this number down real quick. 3.4569. That's such a crazy number. 3.45696. Okay. Okay, so 3.4. Oh, I forgot the number already. 5696. 5696 times 10 to the 3rd. Okay, so that is the distance from Los Angeles to Tampa. Okay, so I'm going to make up my word problem now. So we're going to type this down here. You are flying from Los Angeles to Tampa, comma, but halfway through, let's expand this out so you can see what I'm typing. Halfway through the flight. Halfway is one word. Oh my gosh, it's correcting my grammar. Halfway through the flight, the plane needs to make an emergency stop. Oops. Perfect. How far do you still have to travel to get to Tampa? Okay, so in other words, we're just dividing by 2. Keeping it simple here. We're not trying to do anything special. All right, so we're going to divide by 2. So we're going to take this number and divide by 2. So dividing by 2, so I'm going to turn 2 into a number in scientific notation here. So 2 times 10 to the 0. Anytime you want to turn a normal number in, 10 to the 0. I don't know why I wrote a second. Anytime you want to take like a number and just put it into scientific notation, if it's just a single digit number, you can just write 10 to the 1st, or 0 power, because that's literally times 1. So 2 times 1. Okay, so now I'm going to divide the coefficients. So that's how you do numbers dividing. So we're going to divide the coefficients, which was that crazy number again, 3.45652. Is that the right number? Oh, 45696. I was way off. 45696 divided by 2 is 1.72848. Okay. So it's equal to 1.72848, and we subtract the exponents. So 3 minus 0 is 10 to the third. This is a number, so this number already is in scientific notation, or this coefficient is a number between 1 and 10, so we're good. So we would still have to travel half the distance, which would be that many miles, or you could just move the decimal place over 3 times, and it would be 1,728.48 miles left to travel. Either one of these would be correct. All right, guys, that is it for the portfolio. As I mentioned, we are not doing number 3 or 4. So we are done when you finish up with this last part, letter C, for question number 2. So if you guys have any questions, feel free to reach out. Otherwise, have a fantastic rest of your day. And again, just as a reminder, PDF is probably the easiest way to do it, and if you click here, that'll give you the PDF that you can just type into, and you can also, if you open it up in Microsoft Edge specifically, which is this icon right here, that's Microsoft Edge, then you will be able to draw on it as well. You will not be able to do that in Chrome unless you have a special extension, which I don't know what that special extension would be. So, or if you download this version here, this is the the Google Doc, and then you can make a copy. Again, it's a lot easier to do the PDF because you can draw on it, and it's a lot easier to do math if you can draw. I highly recommend doing it that way. This recording will be available here, and you can use the numbers that I used. Absolutely. You can, of course, choose different numbers if you want to challenge yourself a little bit. Absolutely do that, but you don't have to. All right. See you guys in the next live lesson recording.